So this is question 1 of 2008, and we're looking at a tugboat towing a ship. Tow rope is shown, pulling on a ship with this much force forwards. And this tells us the masses. The tugboat exerts a constant force of 9.0 for 9 to the 10 for 9 times 10 to the 4 n on the tow rope. Water resistance on the ship as a function of speed is shown in figure 2. So the first part of any questions, you have to understand what's going on. After reading all this, I'm not going to read it again, because I already have converted all these bits of information into a diagram, which is more useful. So we have this tugboat with this much mass, pulling this ship with this force, and this is the water resistance on the ship, pushing the ship backwards. This is resistance. And this will tell us that it increases according to speed. Okay. So first question, I already started a little bit of it. Force, we want to calculate the acceleration of the ship when the tugboat and ship are traveling at 2 meters per second. So what we have here is a bunch of forces. Force, force. So we can figure out the net force pulling it forwards, and then we can use that equals F equals ma. So to solve it, force, I'll write it on this page because it's easier for you to see, is 9 times 10 to the 4n, subtract. So the question was saying when we moved at 2 meters per second, 2 meters per second, minus, that means the force pushing the ship backwards. When the ship is moving forwards at 2 meters per second, this is saying that the resistance equals 2 times 10 to the 4. So our total force is 7 times 10 to the 4. So now we just use force equals ma. But so we have to consider, is this force acting on both of them or acting on one of them? Okay, do we just take the ship or take the tugboat and the ship for the mass? And the answer is this force is only acting on the ship, and this resistance is acting on the ship. So the mass we need is only the ship's. Usually you need both. Be very careful about deciding if you need both or one, but right now this is acting on the ship, this is acting on the ship, therefore mass equals 100 times 10 to the 4. Therefore acceleration equals force on mass equals 7 times 10 to the 4 on 100 times 10 to the 4 equals 7 on 100 equals 0.07 meters per second squared. So that's how much it's accelerating. Okay. After a time, the tugboat and ship are traveling at a constant speed. What is this constant speed? So for it to be constant speed, we know acceleration has to equal 0. And therefore, force has to equal 0. Like net force. Otherwise it'd be moving. So we know this forward force has to equal this backwards force. So where do we find 9 times 10 to the 4 over here? So what speed is he traveling at? 4 meters per second. So our boat is traveling at 4 meters per second. Awesome. Let's see if there's any more questions related to this. No. Okay, next set of questions.